Okay, so it is a rainy day here. Mr. Earth says it's raining. He says, put your name on your paper, put your date on your notes, and title it Systems of Equations. Systems of Equations is how many points that two, in this case we're going to do lines, but really it could be functions. It could be anything that shares two pieces. So if we look at even though this says lines, we can also do two functions. So we're looking at some points at which they share. Okay, so here we're going to look at this line. We know it has y equals mx plus b. So a little review is we know the slope equals 1 and the y-intercept is 2. And then here we know the m is -2 and the y-intercept is 5. So we're going to graph these two equations, and you'll see that when we graph them, they are intersecting lines. They intersect in one point. So because these are intersecting lines, we say they have one solution because they have one point they both share. This is my x and this is my y. If I plug my x and y into the first equation, I get 3 equals 3, and if I plug it into the second equation, I get 3 equals 3. So both of these are points for this line and the one above. So it's a one solution, and we also call it consistent systems. So it consistently has one point that it shares. Okay? The next one we're going to look at is let's see, this one right here. Again, we're going to graph this. So I've got this top one is a y-intercept of -3, and the slope is up 2 over 1. So I can draw that line. And then if I look at this one, the y-intercept is -3, and it goes up 1 over 1. So we'll draw that line. So we can see that they intersect in one spot, and that is 0.21. So again, if I want to check and make sure this is correct, I'll plug 1 in for my y and 2 in for the x, and that'll be 4 minus 3, or I get 1 equals 1, so that works. And again, if I plug in 1 for my y and 2 in for my x, I get 1 equals 1. So this is a one solution, consistent systems of equation. Okay. If we look at this equation, let's see, my slope is 1, and my slope is 1, so it should tell me something about the type of lines. What do you think it is? So when I graph these, this has a y-intercept of -3, and it goes up 1 over 1. This has a y-intercept of 2, and it goes up 1 over 1. These are parallel lines. So the idea of systems of equations is how many solutions do they share? So how many do you think they share? That's right, they share no points. So there's 0 solutions. So if a one solution is consistent, a 0 solution would be inconsistent set of solutions. All right, so now we're going to look at this set right here. So we have this equation, which we need to get into slope-intercept form. So we're going to subtract the x. Don't forget that's -y. So we have -y equals -x plus 2. And then we can't leave that negative, so we'll divide everything by the -1. And that gives me y equals x minus 2. So I have my -2, and it goes up 1 over 1. So now we can draw that. And then here we got to get this into the systems of equations. So we're going to add the 2x over here. So now we'll have 2y equals 2x plus 4. Then we're going to divide through by the 2. And then we'll have y equals x plus 2, which you should, oh, that's negative, oops, sorry, -4, so that would make that -2. So we'll see that these two equations are exactly the same when we put them together. So this equation is y equals x minus 2. So the question is
it turtle?
So the answer here would be all real numbers, because they share every point is the same on each line. So they share every single point. Or we could call this infinite solutions. All right, so that's how many solutions there are. And then this is called a dependent system because they're dependent on each other because they're the same. Okay, so we have one solution, no solutions, all solutions. We have consistent, inconsistent, and dependent. So make sure you have those in your notes. So then we're going to look at this, and I want you to see if you can pick out which one is independent, which one's dependent, and which one's consistent. Or not, I said that wrong. Which one's inconsistent, which one's consistent, and one's dependent. Thank you.